In this lesson, we're going to learn a way to pull out the factors of a polynomial that's greater than degree 2. So it's kind of cool, and what you're going to need to do is probably watch this video a couple times, and then we'll practice it in class. We first need to start off with a couple of theorems, though, and the first one is called the factor theorem. So here's what the factor theorem says. When a polynomial is divided by a binomial, and there is no remainder, that means the binomial is a factor of p of x and c is a root, because factoring is really a form of division. If you can break up a polynomial into factors and there is no remainder, that means that each factor divides evenly into the polynomial. So the next theorem we have to talk about is called the remainder theorem, and it's kind of the converse of the factor theorem. So the remainder theorem states this: when a polynomial p of x is divided by a binomial and there is a remainder r, we can say three things. The first thing we can say is that the binomial x minus c is not a factor of p of x because it's not divided evenly. If there's a remainder, that means it doesn't divide evenly into the polynomial. We can also say that c is not a root of p of x. Obviously, if x minus c is not a factor, then c cannot be a root. Finally, since c is not a root and x minus c is not a factor, if I actually evaluate the function at this potential root c, it's going to be equal to the remainder I would get if I divided the binomial into the polynomial. So basically, p of c is equal to the remainder. So we're going to demonstrate this remainder theorem once we learn an efficient way to divide a binomial into a polynomial. And that efficient way is what we're going to focus on for the rest of this lesson, and it's called synthetic division. Basically what happens is when we divide a binomial into a polynomial using the standard division process, there's a lot of subtracting, there's multiply or dividing, trying to work backwards and to see like how many times does 3x go into x squared or whatever. Synthetic division kind of flips that and uses the easier processes of multiplication and addition instead of dividing and subtracting. So we're going to write down the steps and walk through an example and then practice this quite a bit in class. Alright, I have this big old polynomial function, 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3. I want to divide that function by the binomial x plus 2. So the first thing we have to make sure, and it usually already is in place, is p of x has to be in standard form. So we have our coefficient stepping down. That's okay. What we want to do then, we're not going to deal with the actual variables. We're only going to deal with the coefficients when we do this. And then the variables will be put back in the problem at the end. This is a much more efficient way to deal with this stuff. Okay, so like I said, we're just going to take the coefficients and we're going to list them out. If we are missing a variable, then you need to put a 0 in place of anything that's missing. So p of x, we have 3, 5, negative 4. My x squared term is missing, so I'm putting a 0 in. 7 and 3. You should always have one more coefficient than the degree of the polynomial. 1, 2, 3, 4, 5, 6. It's a degree of 5, so I'm good. The next thing we're going to do is we're going to write the root to the left of the coefficient. So right here, this is my binomial is represented as a factor. My factor is x plus 2. That means the root, or the potential root, is going to be negative 2. So negative 2 is going to go to the left. And then what you need to do is you need to draw a box. So here's the box. You leave a gap because we're going to put some numbers in there, and then I draw a little box at the bottom. This separates out what I'm dividing by what I'm dividing into. So again, keep a gap here because there's going to be some numbers going in here. Your answers will be down here, and what's left here will be the remainder. Okay, so here's the process, and this would be good. You might want to watch this a couple times to make sure you get it. The first thing we need to do is to bring the first coefficient all the way down, because that's how we get started. We don't put any numbers underneath the first coefficient. We bring them all the way down, so that 3 is going to be down here. All right, now what we're going to do is we're going to multiply the coefficient by the root and put the answer right under the next coefficient. So 3 times negative 2 is going to be negative 6. I'm going to put the negative 6 right there. Then what we do is we're just going to add my coefficient, my answer, and put the answer to that down there, put the sum right here, and then repeat the process again. And we keep repeating the process until I'm done. So 5 plus negative 6, you've got to be careful. If you drop a negative sign, the whole thing blows up. 5 plus negative 6 is negative 1, and then I take negative 1 and I multiply it by negative 2. That gives me a positive 2. Negative 4 plus 2 is negative 2. I keep doing this until I'm done. Negative 2 times negative 2 is going to be positive 4. 0 plus 4 is 4. 4 times negative 2 is going to be negative 8. 7 plus negative 8 is negative 1. One last round. Negative 1 times negative 2 is going to be positive 2. Then I add these two together and I have a 5. That's the process of synthetic division. Here's what we get out of it. My answer is going to be what's called the depressed polynomial. That's the quotient, or that's the the quotient, and this is the remainder over here. So this is the remainder. This is called the depressed polynomial. It's 1 degree less than what you started with. So I started with a fifth degree, and this is going to be a 4th degree. These are going to be the coefficients of the terms, or of the variables, in standard form. So what I have ends up being 3x to the 4th minus x cubed minus 2x squared plus 4x minus 1. There's the polynomial, and the remainder is 5. So negative 2 is not a root of this polynomial, but we can still divide it and separate it out into what's left over and a remainder. We're going to work one more example here, and then we'll practice this in class and test out some of the original remainder theorem in class. Okay, so here's the example we're going to work. I'm going to divide p of x is equal to x cubed minus x squared minus 5x minus 3. I want to divide that by the binomial x minus 3. So the first thing, we're in standard form. The first thing we need to do is to take the coefficients and write them out. We have a 1, a negative 1, a negative 5, and a negative 3. 1, 2, 3, 4. It's a 3rd degree. They're all accounted for there. I'm going to draw in my boxes. There's my remainder box. And now, since I'm dividing by x minus 3, the root is positive 3. So here's the process. I'm going to bring the first coefficient all the way down to get everything started. Then you take the 1, multiply by the 3, put the answer under the next coefficient. 1 times 3 is 3, and now you're going to add these two together, and my answer is going to be down here. Negative 1 plus 3 is 2. And we keep doing this. 2 times 3 is going to be 6. Add them together, that's 1. 1 times 3 is going to be 3. And now when I add these two together, I get a remainder of 0. So, what does that mean when I have a remainder of 0? That's what I'm going to ask you in class, if I remember to do that. My depressed polynomial is going to look like this. Or I can actually break out that polynomial now. I just divided, I just pulled out this x minus 3, and so now I have x squared plus 2x plus 1. And I have a remainder of 0. So that's synthetic division. I would advise you to watch the process again, because kids you don't, some common errors is that you don't bring the coefficient all the way down. You start subtracting instead of adding. You miss coefficients. There's a lot of little mistakes. But once you get the process down, it's really easy, and it's so much easier than trying to divide the old way with the standard way that we used to do this. So we will practice more of this in class.